Alright, so we are at the word problems part for chapter 6, systems of linear equations. On the top here you'll notice that there are some suggestions of how to tackle some of these word problems. I would just say that, the most challenging thing is step 3, right? Step 3. It's kind of, once you set up the problem, everything else should be pretty easy since it's just kind of the math of it. Let's start with this first one. The sum of two numbers is 45. Their difference is 7. Find the numbers. So we don't know these two numbers. So I'm going to put some let statements. So I got to define the variables. X is one of the numbers and y is the other number. The sum means that my first equation is going to be an addition problem. And the sum of these two numbers is 45. So there's my first equation. My second equation says their difference is 7. So difference is subtraction. So there's my second equation. So now we have x plus y is equal to 45, x minus y is equal to 7, and you just solve it using either substitution or elimination. Looking here, elimination is probably going to be the best bet, so I can eliminate the y's and combine the other terms, and I get that x is equal to 26. And just like normal, you plug 26 into one of the equations and solve for the other variable, y. So y is equal to 19. Now, if we check our answers, 26 and 19 these are two numbers. If I were to add them, do I get 45? If I were to subtract them, do I get 7? And in both cases, it works. Now, I know normally for math, or the other sections for chapter 6, we were supposed to give an ordered pair. But for this, let's just give a sentence since it's a story problem. One number is 26 and the other number is 19. So that's the first type of problems when they're just talking about numbers, two mystery numbers. If we scroll down, we'll look at some coin problems. So if you read through this problem, Mario has 25 coins, a mixture of dimes and quarters. And then the value of all these coins is $4.60. So there are two numbers here, or two equations here. Okay, first let's kind of define the variables. I'm going to use D and Q. So with a lot of these, I'm going to set up the problem for you and then just kind of quickly go through the answers since we already know how to do the math. If D represents the number of dimes and Q represents the number of quarters, you're going to have two types of equations. One of the equations is just going to be straight, how many coins do you have? And then the other equation is the actual value of money. Now let's talk about the actual coins, like how many coins do we have? There are total 25 coins. If you add up dimes and quarters, there are 25 coins. Okay, so that's just the number of coins you have. Dimes and quarters equals 25 coins. Now, when you add a value to it, the value of dimes is 10 cents and the value of quarters is 25 cents. Right, we all know that. So for each dime, it's worth 10 cents, and for each quarter is 25 cents, and the total value is $4.60. So the next equation, we would look at the value of it. So 0.1 times D plus 0.25 times Q equals $4.60. And so again, you can choose whichever, if you want to substitute, sure, you can substitute. If you want to eliminate, you can eliminate. I would probably go through elimination here and multiply the first one maybe by negative 0.1 to eliminate the D's. Whichever method you chose, go ahead and solve for D and Q. Take about a minute, pause the video, and then once you unpause it, I'm going to have just all the answers. Okay, so again, the main thing for this is just, do you know how to set up the problem? Because the math is very easy. So take about a minute and solve it. So once you solve it, we get that there are 11 dimes and 14 quarters that Mario has. Okay, again, the setup is very important. The math, I don't worry about. You guys have shown me that you understand the math. Let's jump down to number 3. It says the bill for 3 glasses of orange juice and 5 pancake specials is $7.60, but the bill for 5 glasses of orange juice and 4 pancake specials is $7.90. What would the bill be for 1 glass of orange juice and 1 pancake special? Let's set the variable first, and then I'm going to have you set up the problem on your own. So let's use J and P. You can choose X and Y, whatever. I'm going to use J and P. I want you look at each sentence and set up a system of equations based on the numbers that they gave you. So I want you to pause the video, write out what you think the equations might be, and then once you unpause it, you'll see the setup. There's your setup. 3 orange juices plus 5 pancake specials cost you $7.60. 5 orange juices plus 4 pancake specials cost $7.90. Now, best method probably here is to do elimination. And that's just my opinion. But I want you to, again, pause the video, take a couple minutes, solve this problem, and be careful of what the question is asking. It's asking what the total price would be for 1 orange juice and 1 pancake special. So go ahead and do that. So there's my work. I eliminated the j's, so I multiplied by 3 and -5. And I got 1 pancake special is $1.10 by itself. And then when I plugged in P to one of the equations, I got a glass of orange juice cost 70 cents by itself. But the question said, what would the bill be if I ordered 1 glass of orange juice and 1 pancake special? So I would add those two together, and so the total would be $1.80. Again, the setup is very important. The math is very easy. Let's flip to the back, and I'm actually going to jump to number 5 and skip number 4 and come back to number 4. Now, I'm skipping to number 5, frankly, because number 5 is a little bit easier. 4 is pretty tricky, and you'll probably need me in class. Number 5 reads, the numerator of a fraction is 3 less than the denominator. If the numerator and denominator are each increased by 1, the value of the resulting fraction is 3/4. Find the original fraction. So let's just define the variable. I'm going to use n for numerator and d for denominator. Now this first sentence says the numerator of a fraction is 3 less than the denominator. So n is 3 less than, so the 3 switches with the denominator, d minus 3. My numerator is the denominator minus 3. Now the second sentence gets a little bit trickier. It says, if the numerator and denominator are both each increased by 1. So let's think about a fraction. I have my original numerator, I have my original denominator. If both of these are increased by 1, then the resulting fraction is 3/4. Okay? Now, does that mean my numerator is 2 and my denominator is 3? No, not necessarily. 3/4 can be an equivalent fraction, so it can be like something unsimplified. So, there are a few things you can do. What I would recommend doing is the easiest. So you have 1 equation and 2 equations, right? The first one and the second one. The first one, n is already by itself. I would probably substitute that right away. I'm going to substitute that into there and get d minus 3 to replace that n, and then plus the 1 that's already there over d plus 1 equals 3/4. And that actually simplifies to d minus 2, right? -3. -3 plus 1 is -2. Now, how do we solve when two fractions are equal to one another? Well, hopefully you're thinking that you can cross multiply. And when you cross multiply, then you actually end up with an equation like that. 3 times the quantity d plus 1, and then 4 times the quantity d minus 2. Take a couple minutes, pause the video, and then solve for what d would be. And then you might as well just get what n is. Now, I solved for d and I got d is equal to 11, and then when I plugged in 11 into this first equation here, since it's the least complicated one, I get my numerator equals 11 minus 3, which is my numerator is 8. Now, let's think about this fraction, okay? So that means the original fraction is 8 over 11. I'm going to write that as a sentence. Let's think about that. The first sentence says, the numerator is 3 less than the denominator. 8 is 3 less than 11. Okay, that works. So, whoops. I'm gonna put a check over that first sentence. And then it says, if the numerator and denominator are each increased by 1, so let's think, if 8 plus 1 is 9, and then 11 plus 1 is 12, so 9 over 12, or I'm just gonna do a side note here, now we get 9 over 12, then it says the resulting fraction is 3/4. 9 over 12 reduces down to 3/4. So that actually works out. So yes, indeed, my original fraction is 8/11. So that's how a fraction problem would work. Now, I'm going to go through number 4. I'm going to tell you that number 4 is the trickiest of them all. Okay. It might require... So I'll introduce it right now. It'll take a few minutes. I'll introduce it right now. And all I'm going to do is I'm going to give you the setup of the problem, and then I'll give you the answer. Okay? And then I'll talk more about it in class the next time I see you. The way numbers work, so we're talking about a 2-digit number, okay? So here, let's read the problem. It says the sum of the digits of a 2-digit number is 12. If the digits are reversed, the new number is 36 more than the original number. Find the original number. What is going on? Let's think about like 2-digit numbers here. Like the number 27, right? 27. That breaks down to like this 2 right here in the tens place, and this 7 is in the units place, right? The 2, it's called the tens place because you're actually doing 10 times 2, right? And then plus 1 times 7, which is just 7, right? There are 2 tens place plus 7 units place, right? So even like, I don't know, 94, we say 90 because you're doing 10 times that 9 to get the 90, and then you're doing 4, right? 86, we say 80 because we're multiplying that 10 by 8 and then adding 6. So hopefully you kind of see this pattern here. So a 2-digit number is 10 times t, so in this case, in our first case, 2, plus u. 10 times that tens place number plus u. And so you'll see that right here. The original number is 10t plus u. Okay? Now, the sum of the digits means if I just take my two numbers and do 9 plus 4, right? Or just t plus u. That's the sum of the digits, t plus u. Now, the reverse is where it gets a little bit crazy, okay? So we have 10t plus u, but then if I switch 27 and flip its place, then it becomes 72, right? But the u was 7. The u was 7, and the t was a 2. So when I reverse this number, it is now 10 times 7 to get the 70 plus the 2. So what I've ultimately done is I've done 10 times u plus t. 10 times u plus t. When I keep, if I call this the original, right? If this is the original number. So that's how I get this statement right here, 10u plus t, okay? Now, again, that's a very brief explanation, and you were probably lost. If you are lost, it's okay. Next time I see you, I will just go over this again, but just for the sake of the video, I'm just going to keep going. Now, to the actual problem, the sum of the digits is 12. So the sum of the digits, t plus u, is 12. Okay, that's my first equation. The second equation says if the digits are reversed, so reversed, I'm using 10u plus t, okay? So if the digits are reversed, then the new number is, or this reverse number is 36 more than the original number, which is 10t plus u. So 36 more than 10, it looks like 16, 10t plus u. What just happened? Again, if I missed you, right, if you just missed that right now, it's okay, all right? I want you to just practice the other four, because those are a little bit easier, and this one, again, is the hardest one, so I'll talk about this the next time I see you in class. If some of you caught this, great, okay? I would suggest using this as substitution, using this guy as substitution and just solving for something by itself, okay? I'm going to go ahead and actually solve it, and then show you the number, okay? And I'll talk about the problem again. Okay, so I solved it by substitution. I got t by itself, and then in the other equation, I just plugged in everything for t, and my u ended up being 8. And then when I plugged in the 8, my t was equal to 4. So my number, the original 2-digit number, happened to be 48. Now let's think about that. Go back to the first sentence. The sum of the digits is 12. 4 plus 8 is 12. That works. If the digits are reversed, so that means the reverse of 48 is 84. So if I were to reverse the 48, I would get 84. Then this new number is 36 more than the original number. Let's see, 84 minus 48 is 36. So that actually is the correct number. So this is correct. Again, I probably lost a lot of you. That's okay. I want to talk about this in class. Try the first worksheet and just practice the ones that you know based on the notes. Okay?